The last piece of the puzzle I want to talk about here is really the most exciting for me, and you'll see why in a second. This is using augmented intelligence to review programming assignment submission. So this is what you guys do when you're going to be evaluated in terms of your programming assignment. And let's talk about that. So I've been using this for the past 3 or 4 days because I did this over the weekend. I came up with a really cool thing we're going to talk about in order to be able to streamline and improve and scale programming assignment submission review for this course. Now, why do we have to do this in the first place? Well, there's a couple reasons. If you've taken any of my classes before, you know that heretofore, when I gave the program specifications, I would be fairly detailed in terms of what you needed to do, the steps you needed to do in order to be able to do the programming assignment. Worked pretty well, people could follow along, helped to demystify some things, and it also helped us write very carefully crafted unit tests to see if your solutions were correct. But there was a problem that started about 6 months ago. It's trivial to take a programming assignment with detailed specs, give it to ChatGPT, and it will generate the solution for you. And I tried this like the day before I released assignment 1 in this class. I thought, gee, let me see whether it's good enough to reverse engineer the solution from the spec. And it was. So I was like, oh my God, what am I going to do? So, and I tried it. I actually typed in the spec, and I took all the code out, just had the detailed specification. It generated a solution that was almost exactly like my solution. So that's a bad thing. So what we did is we stepped back, and we now have much higher level specs. They don't go into as much detail about do this, do this, do this. It's more like, here's the requirement, you can do the implementation. But this creates a whole new set of problems, because now there's lots of different ways that you can solve the solutions, which is good because it gives you more creativity in doing what you're doing. You're not forced into the Procrustean bed of my preferred way of doing things, but it makes it much more difficult to assess what you're doing in any scalable, sensible way. In particular, we can't really check your solutions anymore for correctness, using the word in quotes, using what we have done up to this point, which is white box testing and mocking. If you've ever looked at the tests, the unit tests, they're all a bunch of things written in Kotlin, and they check certain properties of the code, expecting things in a certain order, with a certain sequence, with certain parameters. But if you're now able to be more creative, these tests don't really do a good job. They're going to give you a lot of false positives. They're going to say your code is wrong when your code is not wrong. It's just not the way the test thought they should be done. So this created a whole bunch of different headaches. So last weekend, I sat down and said, I'm going to try to fix this problem, and I'm going to use my good friend ChatGPT to help me out. So let's first just quickly review how the assessment process works for assignments. So there's an assignment that's due on a certain date for the initial submission. You submit your program to me. I read everybody's code. I give you comments about what things to be improved, could be improved, and then I extract those comments and I put them into a file which I call the frequently made mistakes file. And then I make a video that describes the frequently made mistakes, and then I push my comments to your code back to your repos. We have the video. You watch the video, you fix your code, then you resubmit for final grading. So I've been doing this for years, and it's useful to do this because I have a pretty good idea of more or less what people are going to get wrong. But up to this point, the only thing I could do to leverage that knowledge was the next year when I taught the course, a year later, then I had a good idea of what to look for. But I couldn't automate this. I couldn't get anybody else except me to do this. My TAs often don't have enough knowledge to catch these kinds of problems. So what we're doing now is we've come up with a way to automate or semi-automate the means of assessing solutions after the initial review. So I'm still going through the code, still looking at your code, still coming up with comments on your code, but instead of just putting them into a file that then you have to manually read, I'm doing something else, and we're going to take a look at that something else in a second. I'm coming up with English language descriptions of the problems that I see in one of two ways. Either things you should have had in your solution but didn't, like using the common fork join pool, or things that you did have in your solutions but shouldn't have, like calling fork or join in the wrong places, or calling traditional index-based for loops, or using try catch block. There's a whole myriad of things you're not supposed to do. And so as I go through your code now, in addition to doing this, I'm also writing down in English language queries things that should or should not be done. And then I train ChatGPT in order to be able to do that assessment for me or with me. So I'll show you how this works in a second. It's really cool. And what was interesting about this is over the weekend, I started working on this on Saturday, and I thought I'll knock this out in no time. Well, of course, it didn't work. And I was trying to use the advanced data analytics feature with ChatGPT 4, where you give it files and it generates Python code to do the analysis. And it couldn't parse the Java files correctly. It was really slow. I was like, and it kept giving me inconsistent results. I'm like, wow, all the skeptics are right. This is just a bunch of hooey, it's unreliable, it doesn't work. I hate myself, right? And then as I worked on it and I talked to some of my buddies like Jesse Spencer Smith or Jules White, who are way further advanced than I am on this stuff, they pointed a few things out. First, they said, don't use the advanced data analytics for certain things because it's way slower and often incorrect. Put the stuff into the chat window. I was like, well, that's a pretty interesting observation. I didn't realize that. That made the parsing problems go away. The chat window, for God knows why reason, can parse Java code really well. Pretty neat. Whereas the other stuff with the ADA, advanced data analytics, couldn't parse it worth a darn. And then they also said, make sure that you work with ChatGPT when it fails to find the things it's looking for. Work with it. Ask it questions. And this is really cool. So what I did was when it wouldn't do something correctly that I knew needed to be found or not found, and I knew was in the file, rather than throw up my hands and say, large language models suck, I engaged in a dialogue with ChatGPT. I would say, your answer to question 6 was incorrect. Please help me rephrase this question so you answer it correctly the first time. And lo and behold, it says, oh, you need to rephrase this to give me more context. ChatGPT loves context. LLMs love context. The more context, the better. They said, rephrase this to explain what you mean by an index-based for loop, rather than just assuming I am an all-knowledgeable, all-powerful AI wizard that can read your mind. This, by the way, is why prompt engineering is so important. People don't understand you don't just get good results by just asking anything you want to the LLM. You have to say it in a way that it can understand, and the context is helpful. This is super cool. Good luck going to your favorite static analysis tool. Good luck going to your IDE when you get something wrong and asking it, how can I fix my code so it'll work better? The compiler will tell you when you're wrong, but it won't tell you how to fix it most of the time. Your static analysis tool, using some obscure notation, will not tell you how to write the notation correctly. ChatGPT did that. Super duper duper cool. And I'll show you this in a second. You really have to see it run to get an appreciation for it. But what it does is it'll take a prompt. I'll show you the prompt with a bunch of questions, and then it'll go through and check the code chunk by chunk, method by method, and find the things that are either missing, that should be there, or present but shouldn't be there. And this is going to massively streamline the assessment process once we get this automated a bit more. Because now when we get to that last stage where I provided you with comments, you've updated your code, hopefully addressing my comments, and now we have the graders going to give you a score, they can use this in order to quickly see whether there's still problems in your code. And what I'm hoping at some point is we'll get this far enough along where we can use these things in conjunction with the existing white box tests that we have. So you can do some of this stuff yourself to see what's good or bad. But major, major improvement. It also addresses another big problem we have in computer science courses, not so much this course, but the intro courses where we've got dozens and dozens of students. In CS 1101, CS 2201, we have armies of TAs, dozens of TAs, and dozens of graders, I should say, who grade the assignment. There's a tricky thing when you've got dozens of people doing something, and it's called inter-reviewer reliability. Even if everybody gets the same rubric, if they're grading it by hand, chances are some people will be hard graders, some people will be easy graders. Makes it very difficult for the faculty to know whether a score was because the grader was easy or hard, or whether the person actually did what they did. These kinds of techniques will make it much easier to get consistent reviews. Now, the idea here is not just to blindly use these tools to give you grades. It's to use the tools to try to identify where there are problems that lurk even after you've addressed my comments, to more quickly figure out how to score things correctly. And that's the key point here. It's not about replacing people. It's augmenting them so they do a more thorough job at stuff that, quite honestly, can be a little bit, tedious isn't quite the right word, but daunting is the right word. When you're reading through a lot of code, after a while, your brain starts to turn to mush. And the nice thing about things like these augmented intelligence tools is their brains don't turn to mush in quite the same way, which is good. They don't get tired. They don't need to take a break. They do need sometimes to work properly when you're dealing with the quirks of the cloud. So this is an example of a spec of a prompt that I am giving ChatGPT to check code. So it's a bit long. I won't read all the things to you, but basically what I'm telling it is I'm going to give you a Java class, and I want you to use your most advanced method to parse this class. And what you should do is look for these methods. You should look for some constructors and methods that have these signatures. This is important because this is providing the LLM with context. It needs this context to do the proper job. So I give it a bunch of things that it should find, and then I tell it to do the following. I say, please apply the following 4-step method before responding to the questions below. I'm going to give you some questions. I'm going to give you some code. Carefully inspect the code line by line in each method and print summaries of what it's doing before answering the specific question. Provide line numbers, method names, and/or code snippets to justify your responses. Never give a yes or no answer without double checking your analysis, and ask me if you don't understand my question. And so then I give it a bunch of questions. And these are things that either should or should not be in the code. First thing I do is say, please print out the implementations that you found. And then what we do is I say, is there a fork method in the perform crawl method? That's something I found that shouldn't have been there in my review. Is there a join method? Is there a submit method? These are all things where people were adding incorrectly to their solution. Then I start asking questions about things that should be there. Is the perform crawl method using the common pool to use the common pool? Is it using the invoke method on the common pool? Is it creating a new fork join pool instance, which it should not do? Is it calling the shutdown method, which it should not do? Is it using try catch blocks, et cetera, et cetera, et cetera? These are all the things that I identified when I reviewed the code. And now I'm describing what I'm looking for in natural language, and it's going to figure out the answers to these questions. So, key point to come away with from all this discussion. You are the beginning of the new generation of learners. Just as we've had major technological innovations that have radically reshaped the world, the printing press in the 15th century, the steam engine in the 18th century, electricity in the 19th century, the internet, computers, we now have generative AI and augmented intelligence. That's the new thing. And you are at the absolute beginning of all this. Super duper exciting. A couple things to keep in mind. Were you to pursue a traditional programming path where you wanted to go off to be a Java programmer or a web developer or a programmer of embedded systems, you've got a good background. You went to Vanderbilt. You're taking computer science classes. You're doing well. But when you get done, there'll be a lot of people out there who have potentially a lot more experience than you do in embedded systems, in web development, in whatever. So if you go to compete for a job and somebody else has 30 years of experience with embedded systems programming and you have a degree from Vanderbilt, by the way, great job, they still might get ahead because they have more experience. However, when you graduate, there'll be nobody on the face of the earth who has more than about 6 to 8 months of knowledge of prompt engineering. It's an absolutely level playing field. And so the people who figure out how to use this stuff are going to take over the world, literally, because they're going to be so far ahead. Much more productive, much more able to sift out the BS hallucinogenic answers that these things will give you if you don't use them properly from the ones that are useful. And it's an amazing time because nobody else is going to have that background. So I strongly encourage you to pay attention to what's happening here, to learn how to use the tools. My experience from this past weekend taught me that using the tools properly and using prompt engineering properly makes a huge difference in the ability to actually get these things to do what we want them to do. So, as they say at the end of Dirty Dancing, have the time of your life. This is a really great time to be doing stuff in technology. And that is the end of this discussion.